Welcome students in the organic chemistry lecture series. Today in this video we are going to study about the RS nomenclature of stereoisomers. In previous videos we have seen the DL notation, erythro and trio nomenclature and E and Z nomenclature of stereoisomers. In this video we are going to see about the RS nomenclature. Okay. So this general method of nomenclature of optical isomers uh, has some rules, and that rules we have to follow. And this is the most famous method to give the configurational names to the optical isomers. Okay, and which are called as generally R and S isomers. Then the enantiomers, which are two distinct isomers, can be distinguished by adding the prefix R or S to their IUPAC name. These R and S descriptors are assigned on the basis of some rules, and these rules are called as sequence rule. Each group attached to the chiral center is assigned a priority on the basis of Kahn, Ingold, and Prelog system. So, which is called as CIP rules. Okay, based on these rules, what is the CIP? It is Kahn, Ingold, Prelog. These are the names of scientists who discovered this system of nomenclature, and they devised the rules for this nomenclature. Now, according to this, the first rule is that rule number one is that the four groups attached to the stereogenic centers are arranged. The groups attached to the stereogenic center What is stereogenic center? Stereogenic center means a carbon which is attached to four different groups. Okay, so the groups attached to the stereogenic center are arranged in a sequence in the decreasing order of decreasing order of their atomic numbers. Now this is very simple and very important system of nomenclature. Atomic numbers of the atoms. Now I will take one example. Say for example there is one carbon and which is attached to four different groups, say like chlorine, bromine, fluorine, and H, hydrogen. Okay, now you see here what is the atomic number of chlorine, what is the atomic number of bromine, and what is the atomic number of fluorine. We know this. Now out of these three halogen, bromine atomic number is highest, so bromine will get first priority. Okay, then atomic number of chlorine is highest, so it will get second priority. Then atomic number of fluorine is 3, so it will get fourth priority, and atomic number of hydrogen is 4, so it will get fourth priority. So depending upon the atomic number, we have given the priority to the groups which are attached to this carbon. So bromine has highest priority and hydrogen has the lowest priorities. Okay, so this is the first rule. Okay, now I will take another example so that you will easily understand. Suppose here is a CSA group, here is a suppose of OH group, here is the bromine, and here is suppose hydrogen. Now in this case, again we know that bromine has first atomic number highest, so it will get first priority. Then this oxygen will get second priority, this carbon will get third priority, and hydrogen will get fourth priority. Okay, so this is the rule 1. What rule 1 says? The groups attached to the stereogenic centers are arranged in a sequence in the decreasing order of their atomic numbers of the atom. The group must be directly attached to the central stereogenic carbon. So in this way, the priority is assigned to the groups which are directly attached to the carbon. Now this is group. This is rule number one. Now we'll see rule number second. Okay, now see the rule number second. What rule number two is saying? If the two isotopes of the same elements are bonded to the stereogenic center, then assign the priorities in order of decreasing mass number. Now see this example. Now if we have to give the priorities, then we know that oxygen has 8 atomic number, so it will have first priority. After oxygen, carbon will have the second priority because it has 6 atomic number. Now if we compare this hydrogen and deuterium, now these two are the isotopes of each other. That means their atomic number is same. What is atomic number of hydrogen? It is 1. Atomic number of deuterium is also 1. So on the basis of atomic number, we cannot give the priority to these isotopes. So we have to compare their mass number. Now atomic mass of this hydrogen is 1. Atomic mass of this deuterium is 2. So that's why this deuterium will get the third priority. Okay, and hydrogen will get the fourth priority. So if the two isotopes of the same elements are bonded to the stereogenic center, then assign the priorities in order of their decreasing mass number. So this is the rule number second. Now we'll move into the next rule. Okay. Now consider the rule number 3, which is also very important. Now what is the rule say? If the two or more atoms attached to the chiral center are same, then the correct order is found by comparing the sum of atomic numbers of the next set of atoms attached to those atoms. Now you see this example, you will be clear about this rule. Now as per our first rule, this oxygen will have first priority. Okay. Now second priority, for second priority, see here is also carbon, here is also carbon. That means if two or more atoms attached to the chiral center are same. Now this carbon and this carbon are same. So atomic number of from the atomic number, it is very difficult to assign the priority to these two groups. So what to do? So we have to consider the next set of groups. Or next set of group means to which atom this carbon is attached. See here, this carbon is attached here to three hydrogen atoms. Three hydrogen atoms. What is the sum of atomic number of these three hydrogen? It will become 1 plus 1 plus 1. So it is 3. Now see here. Now this carbon is attached to 2 hydrogen. That means 1 plus 1. And again it is attached to 1 carbon. That means 6. Okay. So that means here sum of atomic number comes as a 8. Okay. 8. So among these two carbon, which carbon is having highest priority? So this carbon is having highest priority. So second number goes to this carbon, third number goes to this carbon, and lowest priority goes to this carbon. So I think it is very simple. So if the two atoms are same, then we have to consider the next set of atoms to which these atoms are attached to determine the priority. So I think this rule is clear to you. So we'll move to the next rule. Okay. Now consider this rule number 4. It is the extension of rule number 3, we can say. Now as per rule number 1, first of all we will give the highest priority to this OH group. Okay. Now this carbon and this carbon is the same. So we have to consider the another set of atoms to which this carbon is attached as per rule number 3. Now here this carbon is attached to 3 hydrogen. That means its sum is 3. Here this carbon is attached to nitrogen. Now this rule number 4 says that, now see the bonding between carbon and nitrogen, we know that there is a triple bond. So if 3 bonds are there, then we have to consider 3 nitrogens like this. So this is the rule. That means if atomic number of nitrogen is 7, so 7, 7, 7. So the sum will be 21 like this. We have to consider. Okay. So first priority is to this oxygen, second priority will goes to this carbon, third priority will goes to this carbon, and fourth priority will go to the hydrogen. So this is the rule. Again I will take one example so that it will be clear. See, first priority will goes to this bromine. Now second priority, this is also carbon, this is also carbon. Now see second set of atom, this carbon attached to 3 hydrogen, that means 1 plus 1 plus 1, it is 3. Now see, this carbon is attached to one hydrogen, and one hydrogen means 1, and this carbon is again attached to the double bond. Okay, that means we have to consider it as a like this. So 8 plus 8 16, so 1 plus 8 plus 8, so it will come as a 17. Okay, so ultimately this CHO group will get the second highest priority, then this carbon will get third priority, and this hydrogen will get fourth priority. So what is the fourth rule? When a multiple bond is present, both the atoms attached to the double bond are tripled bond are considered to be doubled or tripled. So that means if double bond is there, then we have to consider this atom as a twice, like this C double bond over here we have considered oxygen twice. If triple bond is there, then we have to consider that atom thrice. Here, like here we have considered nitrogen here 3 times. Okay, so this is the rule number 4. So we'll move further. Okay, now consider the example, and we have to use whatever rules we have seen earlier. I will take one example, CS3 Br, and suppose here is the OH. Now we will give the RS nomenclature to this compound. Now as per rules which we have seen earlier, this oxygen will get first priority. Sorry, not oxygen will get first priority. Bromine will get the first priority. Okay, so the bromine will get the first priority. Okay, bromine will get the first priority because bromine's atomic number is highest. Then second priority will goes to this oxygen, third priority will goes to this carbon, and fourth priority will goes to this hydrogen. Now rotate the sequence. See, from 1 to 2, 2 to 3, 3 to 4. Okay, so which direction is this? This is clockwise or anti-clockwise? This is anti-clockwise direction. Anti-clockwise. So if anti-clockwise direction is there, then it is yes. Okay, so what is the nomenclature of this? It is yes nomenclature. Okay, I will take another example. I will take same example. I have to say one rule. Suppose here is a hydrogen now, and suppose bromine is here, CS3 is here, and OH is here. Now we know the numbering. This bromine will get first number, oxygen will get second, carbon will get third, and hydrogen will get fourth number. Again, how it rotates? Say from 1 to 2, 2 to 3, and 3 to 4. Okay, so we will observe here that again it is anti-clockwise, right? Anti-clockwise, so it is yes. Okay, now what is I am talking is very important. Remember, always remember that lowest priority group should be at vertical line, and if it is not on vertical line, then configuration changes. It is called as conversion rule. For example, now here is yes configuration. As per the direction of this rotation, it is yes configuration, but as you see here, hydrogen is not on vertical line. This configuration changes to R. So the configuration of this is R. This is called as conversion rule. Remember, it is very important. Lots of students do not understand this rule. It is very simple. If you are going to read from the books, you will not understand what is this rule. I am saying it in very simple language. Just find out the configuration, what comes, and after that you see whether the lowest priority group is on vertical line or horizontal line. If it is on vertical line, then whatever configuration is there, it's okay. If it is on horizontal line, the whatever configuration comes, it will changes to another configuration. So here there was S configuration, it changes to R configuration. Okay, so in this video we have seen the very important RS nomenclature of system rules and a few examples. In next video I am going to give a lot of example of this system, so that all rules and this system will get clear to you. So it was just rules introduction to this system. We'll see in detail in the next video. So have a nice day. We'll meet in the next video.